Our sun has been lighting up the sky for 4.6 billion years, burning at a scorching 5,800 degrees Celsius and blasting energy across 93 million miles of space. Without it, Earth would freeze solid in about 8 days. Pretty essential, right? But what if we decided to get a little crazy with our solar system? What if we yanked out our reliable old sun and dropped in something way more extreme? Something that doesn't give off light at all. Something that devours everything around it, including light itself. What if we swapped our sun with a black hole? Now, before you start panicking about being sucked into oblivion, let's think about this scientifically. Would Earth instantly get pulled into a cosmic death spiral? Would we freeze to death in complete darkness? Or would something even weirder happen? Today, we're diving deep into one of the most terrifying what-if scenarios in astrophysics. And trust me, the reality is way more fascinating than you might think. Here's what's going to blow your mind. We're not just talking about any random black hole. We're going to explore what happens with different types of these cosmic monsters. From a black hole with the exact same mass as our sun, to stellar black holes, all the way up to the supermassive giants that lurk at the center of galaxies. Each one would create a completely different nightmare scenario for our little blue planet. But first, let's get one thing straight about black holes. They're not cosmic vacuum cleaners that suck up everything in sight. That's Hollywood nonsense. A black hole only becomes dangerous when you get really, really close to something called the event horizon. That's the point of no return, where gravity becomes so intense that not even light can escape. Think of it as the ultimate cosmic trap door. So what happens if we replace our sun with a black hole that has exactly the same mass? This is where things get interesting. Gravitationally speaking, absolutely nothing would change about Earth's orbit. We'd still circle around at the same distance, taking the same 365 days to complete one lap. The gravitational pull would be identical, because mass equals gravitational strength, and we're keeping the mass the same. But here's where the nightmare begins. No more sunlight. Ever. Within minutes of the swap, Earth would be plunged into absolute darkness. The temperature would start dropping immediately. In the first week, the average global temperature would plummet from a comfortable 15 degrees Celsius to minus 18 degrees. That's when the real problems start. Plants would begin dying within days. No photosynthesis means no oxygen production and no food chain. The oceans would start freezing over, but not all at once. The surface would form a thick layer of ice, but underneath, the water would stay liquid for months, maybe even years. That's actually our best shot at survival, because some life forms around deep-sea thermal vents don't need sunlight at all. Humans wouldn't last long on the surface. Within a month, the average temperature would hit minus 40 degrees Celsius. Most of the atmosphere would literally freeze and fall to the ground as snow. First carbon dioxide, then oxygen, and finally nitrogen. Earth would become a frozen ball of ice and snow, drifting silently through space. But wait, there's a twist. Black holes aren't completely invisible. When matter falls into them, it heats up and glows brilliantly in what's called an accretion disk. If our solar system had enough dust and debris floating around, we might actually see some light as this material spirals into the black hole. It would be a haunting, eerie glow, nothing like the warm yellow light of our sun. Now let's crank up the intensity. What if we swapped our sun with a stellar black hole, something around 10 times more massive? This is where orbital mechanics become our enemy. Earth's orbit would shrink dramatically. We'd be pulled inward, completing our orbit in just a few weeks instead of a year. The tidal forces would be incredible, stretching and squashing our planet like a stress ball. But even that's nothing compared to what happens when we bring in the real monsters. Supermassive black holes, the kind that sit at the center of galaxies, can be millions or even billions of times more massive than our sun. Drop one of those into our solar system, and Earth wouldn't just fall inward. We'd be ripped apart by tidal forces long before reaching the event horizon. The process is called spaghettification, and it's exactly as terrifying as it sounds. The gravitational difference between Earth's near side and far side would become so extreme that our planet would stretch into a long, thin shape before finally breaking apart completely. We wouldn't be orbiting anymore. We'd be cosmic debris. Here's something that'll keep you up at night. As we fall toward any black hole, time itself starts behaving strangely. From our perspective on Earth, clocks would tick normally. But to an outside observer watching from a safe distance, we'd appear to slow down as we approach the event horizon. Eventually, we'd seem to freeze in time, our image getting redder and dimmer until it fades away completely. But what about those accretion disks I mentioned? If a black hole is actively feeding on surrounding matter, it becomes one of the brightest objects in the universe. The material spiraling inward heats up to millions of degrees, blasting out X-rays and gamma rays. Earth would be bombarded with deadly radiation levels thousands of times stronger than anything our sun produces. The radiation wouldn't just kill us slowly. It would strip away Earth's atmosphere in a matter of hours, leaving our planet as a barren, irradiated rock. Any water left on the surface would boil away instantly. Even our magnetic field, which normally protects us from solar radiation, would be completely overwhelmed. We're talking about energy levels so intense they could sterilize the entire surface of Earth multiple times over. Now here's where things get really wild. Let's say we somehow survived the initial transition and found ourselves orbiting a black hole at a stable distance. The sky would be unlike anything you've ever imagined. Instead of a bright sun, you'd see a perfectly black sphere surrounded by a blazing ring of superheated matter. This accretion disk would glow with colors that don't even exist in normal sunlight. Brilliant blues and whites, from temperatures reaching 10 million degrees Celsius. But the weirdest part isn't what you'd see, it's what you wouldn't see. Due to the extreme gravity, light from behind the black hole gets bent around it, creating what's called gravitational lensing. You'd literally see the back of the accretion disk wrapping around the sides of the black hole, creating a bizarre funhouse mirror effect in space. The gravitational time dilation would mess with everything. If Earth were orbiting close enough to experience significant time effects, a single day on our planet might equal weeks or months for someone watching from far away. Your morning coffee would take an eternity to cool down from an outside perspective, while to you, it happens normally. And let's talk about the jets. Many black holes shoot out massive beams of particles and energy from their poles, extending for thousands of light years. These jets move at nearly the speed of light and carry enough energy to power entire galaxies. If Earth happened to be in the path of one of these jets, we wouldn't just be destroyed. We'd be vaporized so completely that not even our atoms would survive the encounter. Here's something that sounds like science fiction, but is absolutely real. If you could somehow survive falling into a black hole, you'd experience something called the firewall paradox. As you cross the event horizon, you might encounter a wall of energy so intense it would incinerate you instantly. Or, according to some theories, you might pass through normally and experience a relatively calm journey toward the center, at least until the tidal forces tear you apart. But what about escape? Once our sun is gone and replaced with a black hole, could humanity find a way out? Theoretically, yes. We'd need to build massive rockets capable of achieving escape velocity from our new orbital prison. The problem is, without sunlight, we'd have no solar power. Without plants, we'd have no oxygen. Without a functioning ecosystem, we'd have no food. We'd be racing against time to develop technology while our entire planet slowly dies around us. The irony is brutal. Black holes are actually some of the most efficient energy sources in the universe. If we could somehow harness the rotational energy of a spinning black hole, we could power human civilization for trillions of years. But getting close enough to do that without dying is the ultimate cosmic catch-22. Even more mind-bending is what happens to space itself around a black hole. Gravity doesn't just pull on matter and energy, it literally warps the fabric of space-time. Near a black hole, space gets twisted and dragged along with the black hole's rotation. This effect, called frame dragging, means that even if you tried to remain stationary, space itself would carry you along for the ride. So what's the final verdict on swapping our sun with a black hole? In every single scenario, it's an absolute catastrophe for life on Earth. Whether we freeze to death in eternal darkness, get torn apart by tidal forces, or get fried by a deadly radiation, there's no happy ending to this cosmic experiment. Our sun might seem ordinary compared to the exotic monsters lurking in deep space, but it's that ordinary, stable, predictable nature that makes life possible. The next time you step outside and feel the warm sunlight on your face, remember that you're experiencing something incredibly rare in the universe. Most of space is cold, dark, and hostile to life. Our sun is the perfect size, the perfect temperature, and the perfect distance away to create the tiny pocket of warmth and light that we call home. So, what have we learned from this cosmic thought experiment? Swapping our sun with a black hole would be the ultimate nightmare scenario, no matter which type we choose. A solar mass black hole would freeze us into a lifeless ice ball. A stellar black hole would crush us with tidal forces. And a supermassive black hole would turn us into cosmic spaghetti before we even knew what hit us. The brutal truth is that our sun isn't just important, it's absolutely irreplaceable. Sure, it might not be the biggest, brightest, or most exotic star in the galaxy, but it's stable, predictable, and perfectly sized to keep us alive for billions of years. It doesn't throw deadly tantrums or blast us with lethal radiation. It just sits there, burning hydrogen into helium, keeping our little corner of the universe warm and bright. Black holes might be the most fascinating objects in the cosmos, but they're also the most dangerous. They represent everything that could go wrong with gravity and space-time. Meanwhile, our humble yellow dwarf star represents everything that went right for life to exist. Next time you complain about a hot summer day or wish for more dramatic sunsets, remember that boring is beautiful when it comes to stars. Our sun's greatest achievement isn't being spectacular, it's being reliable. And in a universe full of cosmic death machines, that reliability is the most precious thing we've got. What do you think? Would you trade our predictable sun for something more exciting? Let me know in the comments below, and don't forget to subscribe for more cosmic catastrophes that will make you appreciate what we've got right here on Earth.